Hello, everybody. Welcome back to our random math problems. We have here a probability problem. A player tosses two fair coins. Two coins are being tossed, and he will win $1 if one head appears, $2 if two heads appear. On the other hand, he will lose $5 if no head appear. Determine his mathematical expected winnings. Right? So we shall see if it's wise for the player to go on and play or not. How many events do we have here? But before that, remember that the general formula in getting the mathematical expected winnings is this one. Probability times X, the price. All right? And we should be able, just a short or a brief review about probability. What is probability? Probability is the ratio between the number of successful outcome or event all over total possible events. All right, so we should be able to recall that. So let's see how many events are there in total. First event, it could be the player wins $1 because there is one head. Out from the two coins being tossed, there is one head. The other one is a tail. Right? So this is the first event. The second event could be tail first, and then the other coin is head. The third event is head and head, both heads. And the worst event, the fourth event, is tail and tail. So for the first event, the player wins how many dollars? Only $1. Because it says here that he wins $1 if there is one head. All right? So regardless if the other coin is a tail, it doesn't matter. The condition says as long as for every event there is one head, you will earn $1. So for the second event, still the player earns $1. And for the best event, when the player got two heads, and in this case, he will be earning $2. However, the worst event is that when there is no head, and he will be losing $5. So that could be negative. All right, so I hope it's clear. So now we already have the prizes. These are the prizes. So that's for the X. Now we need to find out what is the probability of every event. Okay, so how about for this event and this one, since they are both, since these two events are uh, giving the player same amount, so we can keep them together, right? So the question would be how many events, or yeah, how many successful events are there when the player earns $1? How many successful events? So that could be there are two events out of how many total possible events? There are four. So that is 2/4. So this is 1/2, right? So we can write our mathematical expectation here. It's going to be, because there are 4 events, so there are 4 probabilities and also 4 different prices. But since the 2 prices are equal, so basically you can just have 3. Right? So that's going to be summation now. Summation of the product of the probability and the price. Okay, so for the first probability, for this one, the probability for this event is 1/2. We did it here. Okay, so we have 1/2. And what's the price for that? It's $1. And how about for this event? What's the probability for that? The probability for that is, that's only one event out of how many total possible events? 1, 2, 3, 4. So that's only 1/4. So plus the probability is 1/4, and the price is only $2. And how about for the last event? The probability for this is also 1 out of 4. So 1/4, but the player is losing $5. So let's have it -$5. I hope it's clear. And let's simplify 1/2 times 1. So that's only 1/2 plus 1/4 times 2. That is 1/2. And then positive 1/4 times -5. So that's -5/4. So simplifying further, we have 1/2 plus 1/2. That's 1 minus 5/4. Simplifying further, this one can be written as 4 over 4 minus 5/4 is equal to 4 minus 5, that's -1/4. So it's -$0.25. So meaning, in the long run of the play, the player will lose $0.25. So it's not wise for him to play. I hope it's clear. If you have questions, you can comment down your question and I would love to get back to you. Thank you and see you on the next random math problem. Bye-bye.